You are welcome to higher derivatives or successive differentiation. We want to consider successive differentiation or higher derivatives. If you have differential coefficient dy dx and you are asked to do further differentiation, that is, you want to find d dx of dy dx. So to do that, it appears the d's are multiplying and it will be d squared y over ds dx will be dx squared. So it tells you that when you have dy dx and you want to find another differentiation of the dy dx, the differential coefficient, you differentiate again. So what it means is that if you have d squared y over ds squared, it means you have to differentiate the function twice. Similarly, if you are also to differentiate find d dx of d squared y over dx squared. From the analysis I gave, it's just like the d is multiplying d, so it is going to give you the cube y over dx squared times ds and it's dx cube. What it means is that you have to differentiate the function 3 times. That's the meaning of successive differentiation. Example: if y equal to 5x power 6, find d square y over the x squared. We have a function and we have to differentiate twice. So the first derivative solution, we have to find dy dx, which is the first derivative of the function. And per the differentiation rule, dy dx of this function is going to be 30x exponent 5. Then, to differentiate again, it is going to be d square y over the x squared. And the first derivative will be different, the function will be differentiated again, and the result will be 5 times 30. And that one will be 150. X exponent 4. So that is the result. The second derivative. When you differentiate twice, this is the result. Per the rule, you can continue differentiating. So you differentiate 6 times. When you go beyond 6, because the degree is power 6, is 6, when you differentiate beyond 6, the function will go 0. So that is it. Another example. Given that y equal to 3x squared, find d square y over the x squared. It means we have to differentiate the function twice. And solution: dy dx is now going to be 6x. And further derivative, d square y over dx. That is differentiating the first derivative. The result will be 6. And that is the answer for the question. Good. We want to consider product rule in differentiation. The product rule in differentiation, that is, if you have y equal to uv, where both u and v are functions of x. That is, if you have two functions multiplying and you are asked to find the derivative of the product, you can expand, if possible, before you differentiate. But if you can't not expand to, you can use the product rule to find the differential coefficient. So when the function is defined, if y equal to uv, where both u and v are functions of x, the rule says that if you want to find dy dx of this function, you maintain any of them first. So if you want to maintain, you maintain the u function u, then you find dv dx, then plus, you try to find, you maintain the next function, which is v, then you find the derivative of du dx. That is the product rule. You maintain one function, you differentiate the other, then later you maintain the one you have differentiated, then you differentiate the one you didn't differentiate earlier. So maintain, differentiate, and then you maintain. That is the product rule. And it goes beyond when the functions are two. If you have also, if you have y equal to u, v, w, and both u, v, and all the three functions, u, v, w's are functions of x. Per the rule, you can go by the same principle and find the derivative. So in this case, dy dx, dy dx is now going to be, you maintain uv, then you find dw dx, plus you maintained vw, then you find du dx, plus you maintain w u, then you find dv dx. So it holds that if the functions are many, this one can also be done. You keep on maintaining two, then you differentiate one. If they are many, that is how it's supposed to be done. So that is the product rule. You maintain, you differentiate, you maintain the rest. Let's pick an example and see how it can be done. If y equal to 2x plus 1 and then 3x minus 2, the functions are linear functions being multiplied together. So if you want to find the differential coefficient, from here we have to find dy dx. So what we are going to do per the rule, we maintain, we differentiate, we maintain. Or you can expand